So the order here is 150 milligrams of the drug, and the label says we have 500 milligrams, a multiple dose vial. The reconstitution instructions say we should add 1.8 mils of sterile diluent to the contents of that vial to yield the concentration of 250 milligrams per mil. The first question is what the volume of the reconstituted medication will be. Well, because it's a vial, we have to reconstitute the whole contents of the vial. The vial comes in with 500 milligrams of the drug, and look at what we have here. The concentration given is this 250 milligrams per mil. So this is our half because we have the two quantities, and the 500 milligrams will act as our want. So this time we'll start with the want over half times the third quantity. So our want in this case, 500 milligrams. Our have has to come from that blue ratio or rate, which is 200 milligrams to match the milligram on top. And then we multiply by the third number, which is, so 500 milligrams gone, 250 milligrams gone. So we have that 1 mil, the invisible 1 there. So we multiply by 1 mil. So to finalize this, we know the milligrams cancel out. 500 divided by 250 is 2, and 2 times 1 is 2 unit mils. So what does this mean? 2 mils is the volume of the reconstituted medication. So once you add 1.8 mils of sterile water to the contents of that vial, you end up with 250 milligrams per mil as a concentration. But if you are reconstituting the whole lot, you have 2 mils. We could even just basically have looked right here and look at the proportions. If 250 milligrams requires 1 mil, for 2 mils, let's write that just under here, for 2 mils, it's double the quantity, so it would be 500 milligrams. So that's why the final volume of the reconstituted medication is 2 mils. That answers the first part of the question. The second part asks us about what we need to administer. So that depends on what the order is. So we have the order right up there. The order is 150 milligrams. And we use, that is our want, because that's what the patient will need. That's what the patient has been prescribed. And what we need here again is the concentration of the drug in blue. So our have will again be the 250 milligrams per mil. Of course, we could use the 500 milligrams per 2 mils, but usually the concentrations we use are the simplified, the smaller quantities. So let's see what we do here. Same thing using the want over have formula. This time we say we want 150 milligrams because that's the order. We have in the blue ratio here, we have 250 milligrams per 1 mil. We need the milligrams. And then we multiply by the third number. So the third number being that 1 mil sitting there. So we do the calculation here. You could do a mental calc first, knowing that 150 divided by 250 is not going to be a whole number. It's going to be less than 1. You can use a calculator. So that means that multiplied by 1 will be a number less than 1. So we are expecting 0 point something. If you use the calculator, you get 0.6. The milligrams cancel out, and our unit ends up being mils. So out of that 2 mils, which is the reconstituted solution, by adding 1.8 mils of water to the contents of the vial, we have those 2 mils, and then we're going to extract and inject 0.6 mils. to satisfy the order. We'll try to do this again using the box method. So just clear that part. And let's move this to the bottom. Right. So analyzing this again, the order is what we want for the patient. But the first question is not about what we are administering, but it's about what the final volume of the reconstituted medication will be. So we need to look at the concentration that we have here, 250 milligrams per 1 ml. This is our have because of that ratio. And the full contents of the vial, 500 milligrams. So that's acting as our want for the first part of the question. So we still use want over have even if we are using the box method. We always start our box entering our have, which in this case is the pink 250 milligrams in each 1 ml. The 500 milligrams needs to sit right next to the 250. You can look at it and see this is increased by 2. So 2 times 250 is 500 milligrams. So this must increase by 2 times as well. So the answer will probably be 2. But we can do the full calc. We can multiply 1 by 500 and divide by 250. And that gives us 2. The unit here should follow the same unit on the left, 2 mils. So 2 mils is the volume of the reconstituted medication after we have added 1.8 mils of diluent to the contents of that vial. The second part of the question, we draw another box. Our have is exactly the same because our have is always going to be the concentration of the drug in these reconstitution questions, 250 milligrams in 1 ml. But this time, the order is our want because that's what we want to administer. So remember the keywords, the patient, the order, administration, and all the other words that go together with what's related to the patient. So we add 150 milligrams matching with the milligrams on the left. We can do a mental calc here as well. It's not exact, but we know it goes down. So the 1 ml needs to go down as well. So it will be 0 point something that we are expecting for an answer. Then we do the calculation, multiplying 1 by 150 and then divided by the third number, the 250. Doing this calculation, you can do it using a calculator or doing some mental calcs there. 0.6, what's the unit? Has to match milliliters. So 0.6 mils is what we are going to administer. So in the full wording, what we could say is add 1.8 mils of sterile diluent to the contents of the 500 milligram vial to yield a concentration of 250 milligrams per ml and extract 150 milligrams to inject intramuscularly.